We are moving on today to Unit 4, Lesson 22. We are going to get into our geometry unit. So today we're going to talk about the area of polygons. Specifically, we're going to talk about rectangles, triangles, and parallelograms. So let's use what we know. The design of this stained glass window includes many different shapes. How much glass is needed to cover one of the parallelograms if its height measures 3 inches and its base measures 8 inches? Well, first of all, we need to know what a parallelogram is. So, parallelogram has 4 equal sides. Obviously, here you can see our parallelogram drawn on the grid. So A says you can draw the parallelogram on the grid paper. Imagine cutting the parallelogram along the dotted line and moving the triangle you just cut off to the other side as shown. If we do that, it takes us from a parallelogram to a rectangle. So then we're back to our base times height. So B says, what kind of shape do you get? Well, we just said that. We get a rectangle. C, how do you find the area of the new shape? We've talked about this before. The area of a rectangle is base times height. That is the same thing as length times width. It's just kind of giving it a different name. But base times height. B is how we represent base. H is how we represent height. So it's B times H. If the base is 8 inches and the height is 3 inches, what is the area of the rectangle? So if we're doing base times height, we replace these with the letters. So our base is 8, our height is 3, and then we multiply. 8 times 3 is 24. And we would label these units squared. E is the area of the parallelogram, the same as the area of the rectangle. Explain your reasoning. Well, if we look back up at that picture in A, we would see we have the exact same area here because you're just taking part of the parallelogram and moving it to the other side. So yes, they have the same area. Because we moved the triangle. They cover the same area. Okay, and then F says, how could you find the area of the parallelogram? Well, if they cover the same area, we just took one piece and moved it to another side, we'd do the same thing as we do here. You would multiply the base times the height. So let's find out more. You saw that the formula for the area of a parallelogram is A, which represents area, equals B times H, which is your base and your height. You can figure out how to find the area of a triangle in much of the same way. Start with a rectangle, then draw a diagonal split to the rectangle in half. So when we do that, you can see that we now have 2 triangles here. The sides of a rectangle are perpendicular to each other, so the triangles you get are right angles. The area of one of the right triangles is half the area of the rectangle. What about the other types of triangles? Start with the parallelogram. Drawing a diagonal splits the parallelogram in half. The area of the parallelogram is A equals B times H. The area of the triangle is half the area of the parallelogram. Okay, so the base is always one of the sides of a triangle. It doesn't have to be the side the triangle is sitting on. The height to the base is always perpendicular segment drawn to the base. Sometimes the height is drawn outside the triangle. Like here, you can see from here to here would be our height because it is perpendicular. Look for the little square to show perpendicular. Okay, so let's put this together. We know the height of a rectangle or a parallelogram is base times height, right? Well, if we are doing half the area, we'd multiply it by 1/2. So the area for a triangle is 1/2 base times height. So you can see here, when we put two triangles together, it makes a parallelogram. So once again, area of a triangle is 1/2 base times height. So let's reflect. Number 1, describe the relationship between the area of a parallelogram and the area of a triangle that have the same base and height. So, like we said up here, the triangle is going to have an area that is half the area of a rectangle or parallelogram. A triangle is half the area of a rectangle or parallelogram. Alright, so let's move on. A part of another stained glass window design is shown below. How much glass would you need for this part of the window? In the picture, you can separate the figure into 2 triangles and 4 parallelograms. And you can see the dark purple lines break the shape into the 4 parallelograms, and the green lines break it into 2 triangles. So on the model it, you can draw one of the parallelograms and one of the triangles and label them with their dimensions. So you can see that our parallelogram, we have a base of 12 centimeters and a height of 3 centimeters. For our triangle, we have a base of 10 centimeters and a height of 3 centimeters. So now we can solve it. You can use the formulas to find the areas of the triangle and the parallelograms to solve the area for the entire figure. The area of a triangle, we would use 1/2 base times height. The area of the parallelogram, we would do base times height. So if I look at our parallelogram, I have a base of 12 and a height of 3. If I look at our triangle, I have 1/2 times our base, which is 10, times our height, which is 3. So to solve for these, I would just multiply them out. 12 times 3 would give us 36, and 10 times 3 is 30, half of 30 is 15. Or I could do half of 10 is 5, and 5 times 3 is 15. Remember, it doesn't matter what order we multiply them in. So let's go through and answer some more questions. Number 2, look at the picture. Explain how you could find the total area of the figure. Well, on the previous page, we went through and we found the area of our parallelogram by doing 12 times 3 for our base times height, right? And we got 36. Then we found the area of one of the triangles, and we did 1/2 times 10, which is our base, times 10, or times 3, is our height. So when we multiplied that out, we got 15. Now, this is just for one triangle and one parallelogram. We have 2 triangles, so I would have to take the 15 times 2, because I have 2 triangles. If one of them is 15, I would multiply it by 2 to get my 2 triangles. So the area for both triangles would be 30. And then we have 4 parallelograms. So if one is 36, I would multiply that by 4 to find out how much it is altogether. And 36 times 4 is 144. Then, what would we do with these? We would add up all the areas for the shape. So we would add those together. So what can you say about the 4 parallelograms and the 2 triangles? The parallelograms are the same shape and size. and the triangles are the same shape and size. Number 4, what is the area of one of the parallelograms? Well, we did this up at the top. The parallelograms would be 12 times 3, which is 36. What is the, and then it says show your work, so here's our work. What is the area of one of the triangles? We did this up above as well, kind of jumped ahead a little bit, and we found 15. Now it says calculate the amount of glass needed for the windows. So we do 36 times 4, because there are 4 of them, and we get 144. And then we do 15 times 2, because there's 2 triangles. And then we add these together. And we get a total of 174, and we are working in square centimeters. So number 6 says, explain how you can find the area of a polygon. Well, we can use the formulas for rectangles, parallelograms, and triangles. We can break polygons into shapes we know. Okay, so basically break down those more difficult shapes into rectangles, parallelograms, and triangles so that it's easier to do. And then once you have each one, you can add them up to get your total. So now I want you to try it. We have a parallelogram for number 7. So remember, area is base times height. Oops, hold on, back up. So area equals base times height. So you'd plug them in and work it out. For 8, we have a triangle, so area equals 1/2 base times height. So plug in your base and plug in your height on each one of them and work it out. Pause the video, work your way through it. Once you finish, resume the video and you can see your answer. Okay, so when I plugged in my base and height, I had 6 times 3.5, which is the same as 3.5. When you multiply those out, you get 21 feet squared. So number 8, I'm doing the same thing. Our base and height are the same, only this time I'm going to multiply it by 1/2 as well. So 6 times 3.5 is 21, and then half of 21 divided by 2. When I did that, you can see that I got 10.5 or 10.5 feet squared. Okay, so the next question says, in art class, Swati created a trapezoid made up of smaller trapezoids that are all the same size and shape. If the height of the large trapezoid is 4 inches and the bases measure 5 inches and 10 inches, what is the area of the large trapezoid? What is the area of one of the small trapezoids? So we can picture it. You can draw the large trapezoid and label it with the information you know. So we have the base across the bottom is 10, the base across the top is 5, and our height is 4. And our model it, you can separate the trapezoid into 2 triangles and 1 rectangle and label their dimensions. So as you can see, basically they took each side off and we have our dimensions. So if the whole base is 10, we know that from here to here is 5. So that's why this is 5. Well, if the whole thing is 10, 10 minus 5 is 5, so that leaves 5 that we have to split among both sides, which is where we get our 2.5 inches, or 2.5 inches. Okay, once we have it broke down, we can then solve it. You can find the area of the triangles and the rectangle to help you solve the problem. So our triangle is 1/2 times 2.5 times 4. So we can do half of 4, which is 2, and then 2 times 2.5. And 2 times 2.5 gives us 5. Then for our rectangle, we do base times height, which would be 4 times 5, which is 20. Now, we have to remember we have 2 triangles, so I multiply this by 2, which gives me 10. So then I can add these two, and I would find that I have a total of 30 inches squared. So let's use this to solve some problems. Number 9, look at, model it. What can you say about the 2 triangles that are part of the trapezoid? Well, they are the same shape and size. Same shape and size. Number 10, how do you know that one of the sides of the triangles is 2.5 inches? Well, we kind of talked through that earlier. The base is 10. And the top is 5. That leaves 5 inches to divide evenly for each triangle. Which is 2.5. Number 11, explain how to calculate the area of the large trapezoid. Show your work. So we have our area of the rectangle. So we would do 5 times 4 equals 20 square inches. And then we have the area of the triangle, which is 1/2 times 2.5 times 4, which is 5 square inches. So when we add these up, it would be 20 plus 5 because there are 2 triangles. So when we add that up, we get 30 square inches. Number 12, what is the area of one of the small trapezoids? Show your work and explain your reasoning. So we know that the large trapezoid is 30 inches. Okay, 30 inches squared. And is made of 16 small, this is a 16, sorry about that, trapezoids. So to find the area, we divide 30 by 16. And we get 1, okay, let's try that again. 1 7/16 square inches. So, once again, I want you to take a moment, pause the video, and work out these 2 trapezoids. Remember, we need to break them into rectangles and triangles. On this one, you're only going to have 1 rectangle, 1 triangle on each. So, for example, I'm going to help you out before you get started. On number 13, we would take and divide, sorry, not a super straight line there, into our rectangle and triangle like this. On number 14, we would do it across here. So, use what you know to help figure out your dimensions for your triangles, and then work them out. Once you're done, resume the video and you can see your answers. Alright, so here you can see your answers. To find out how we get the triangle's dimensions, we have to do 4 minus 3 for our 2 bases, and that shows that we have 1 yard for our triangle. So for our rectangle, we would do the base times height, which is 3 times 7.5, which gives us 22.5. For our triangle, it's 1/2 times 7.5 times 1, which gives us 3.75. We add those together and we get a total of 26.25 square yards. For number 14, to find our missing dimensions for our triangle, we would do 6 minus 4 is 2. So then for our rectangle, we would do 4 times 3.2 to get 12.8. For our triangle, we have 1/2 times 3.2 times 2, which gives us a total of 3.2. We'd add those together and get a total area for the trapezoid of 16 square centimeters. So, if you have any questions, please raise your hand and ask. I can still come help and explain. If you do not have any questions, go ahead and log back into Classroom and go ahead and take the exit ticket. Once you finish, you can work on the independent or the guided practice pages in your instruction workbook on page 226 and 227.